This is Mr. Trask, and we are going to show you how to set up an electric circuit today. Okay, so there's only two things we need for electricity to flow. And the first thing we need is we need a battery. So you can see here I have two 1.5 volt cells to make my battery. And I'm going to plug that into this little light bulb to see if I can make it turn on. Okay, so I'm going to take this cord here and I'm going to plug it into my light bulb like that. And you'll notice that the light bulb doesn't light up. And the reason that light bulb doesn't light up is there's actually a second thing that we need for electricity to flow. And what we need is we need a complete circuit. So I'm going to plug this other end of the light bulb in there, you can see. And the light bulb still doesn't light up because if you look way over here, my switch isn't closed. Okay, so when I close this switch, just go ahead and back up, Van Zandt. Okay, when I close this switch, all right, how exciting. Okay, our light bulb comes on. So we've got a complete circuit. The electricity can flow from the batteries, it can flow through the light bulb, all the way through the circuit, and all the way back to the batteries. All right, now we're gonna get some readings here. So we just get a shot of our voltmeter. You can see our voltmeter reads right around 3 volts. And over here, my ammeter, which is measuring the current, is measuring right around 2 amps. All right, that's it. That's how you set up an electric circuit.
Okay, now it's time to take some notes on electric circuits. So you should have your note sheet in front of you, and you can take notes as we move along. First thing you want to do is record your name in the top right-hand corner. Okay, so from that intro video, hopefully you recognize two things. That in order for electricity to flow through a circuit, we need two things. And the first is a power source. The second thing we need is a complete circuit. And once we have those two things, then electrons will flow around our circuit. Okay, so 3 vocab terms that you're going to have to get used to are voltage, current, and resistance. So voltage is really the amount of energy that the electrons have as they get pushed around inside this circuit. And voltage is measured in volts. The symbol for that is just a capital V. Now, current is really the amount of electrons that are flowing. So the more electrons that you have flowing around your circuit, the greater the current is. And it is measured in amperes, or amps. And the symbol for that is just a capital A. Now the last one here, resistance. Resistance is really how difficult it is for electrons to flow through a certain material. And it is measured in ohms. And the symbol for that is looks kind of like an upside down horseshoe kind of shape. All right, so these are all related to each other through something called Ohm's law. And Ohm's law is a statement that says that resistance is equal to voltage divided by current. So to write that as an equation, we could say resistance is equal to voltage over current. Now, to write that a little more simply and just use a single variable, we say R for resistance is equal to V for voltage divided by I for current. Okay, so let's see how Ohm's law might be applied to a word problem. Okay, imagine Mr. Trask is super excited because he got his new blender and he wants to make some smoothies. He notices that the manual says the blender will draw 3 amps when it's connected to a 120 volt outlet. So what is the resistance of the blender? So with these word problems, first thing we want to do is just go through and pick out the relevant information. So 3 amps, that's a measure of my current. It's measured in amps. It's talking about how much it's going to draw. And 120 volt, that is a measure of the voltage, or the energy that's being supplied to each of those electrons. So if I look back at Ohm's law, I realize that the resistance is just going to be the voltage divided by the current. And in this case, that's 120 volts divided by 3 amps. Now 120 divided by 3 is 40. And since it's a measure of resistance here, the unit that I need to include is ohms. So my answer is 40 ohms. All right, don't forget to do the recap.